Thank you very much. And I want to say thank you, Mr. Mittal. The way you have explained the things today, it has been an eye opener. It has been an absolutely an eye opener. And some of the things which you want to see, the government of India has been very, very supportive of the green hydrogen mission. And this is the statement which you see. This is a statement given by the government of India. Green hydrogen, they have given a flexibility that carbon footprint, which is up to 2 kilogram of uh, carbon dioxide per kg of hydrogen. That's a relaxation which the government has given. In the Western world, it is half a kg. So government is fully supportive of that. Second area where the government has given uh, clearance is that we can do the power banking. That's what Mr. Mittal was just talking about. We can produce the solar power, we can put it into the grid, and later on we can withdraw that power. Normally, otherwise, you can have only 20% of the power which you can produce and deliver it. Coming down to a standard, what Mr. Mittal was just talking about, producing a green hydrogen is not something very complex. It's a straightforward. You are producing the power, solar power, and putting it into the grid, and then you can withdraw the power at any point in the country and produce the green hydrogen. And green hydrogen, then you can use it for fuel, you can use it for industrial purpose, and you can liquefy it and then transport it out to the various parts in the world. So what Jacobs Engineering is currently doing is they are working out on a complete ecosystem on green hydrogen. So produce the green hydrogen, liquefy it, bring it to the jetty, put it into the container, ship it out, and normally the way it is going to work out is Singapore is going to become a terminal where all the exchange, hydrogen, trading is going to happen. So most of the people are going to put the plant near to the seashore, liquefy it, transport it, and it's available for shipping it to the other Asian countries. And one thing I just want to tell you is Jacobs has got a capability on all the areas, right from generating the solar power to the producing the green hydrogen, stabilization of the grid, and then using it for the various purpose. Now, the biggest currently, the low-hanging fruit, if you are the entrepreneur here in the room, the low-hanging fruit which is there is the green hydrogen which is required by the refineries. Currently, the people are producing the green hydrogen in the refinery from the methane route. What they are doing it is they are doing the steam reforming, and with the steam reforming, they are using the green hydrogen, they are using the hydrogen which is a gray hydrogen. It costs about 250 rupees per kg. But now comes the economics, how we are going to do the economics. So this is the standard flow diagram where you see how the industrial use which is being done. You produce the green hydrogen, pump it with the compressor, and send it out to the refinery. You need to put the green hydrogen plant near to the refinery, and you can withdraw the power from the grid near to the refinery and then just pump it. And today we are working out with several refineries. One of them is in the Punjab itself, where we are going to produce a green power in Rajasthan, and then downloading the power in Punjab, and then produce the green hydrogen near to the refinery and give it to the refinery. So that's the way the things are moving. It's the most low-hanging fruit. Green hydrogen technology, as it was talked about, it's a very simple technology, and it's a alkaline electrolysis. That's the most common green hydrogen technology which we are using it. John Cockrell, other companies like Thyssen Group, all of them, they have got a standard technology. It's not a rocket science. But where the problem comes is we are importing all the electrolyzer from the other parts of the world, and it is making us very expensive. If the cost of producing, uh, if the cost of the plant is 12 crore rupees per megawatt, that's the cost. 7.5 crores is the cost of the electrolyzer itself. If we can produce the electrolyzer in the country, then we can really produce the power, produce the green hydrogen in a much, much cheaper way. I'll say is the other technologies, solid oxide electrolysis, not very well developed. If you see the polyelectrolyte membrane technology, not very well uh, developed. So currently the people are all working on alkaline electrolyzer technology. Coming back to the system, which we say is safety, the most important part is the safety. When we are going to ship the green hydrogen, we have to use the standard transport quality material, which is as per ISO 14697. The compression system would be required to pressurize the tube trailers. They are going to be, normally it is in the range of about 300 to 1000 kgs. 500 kg is the normal trailer. Compressed green hydrogen is transported into those containers. Safety approaches, they need to be meeting the requirement on hazardous area classification. Some of you are, who are the engineers, you must be saying that these are the hazardous area classification, which is zone 1, which we need to use it, which is group 2C. And then, for example, we need to use the guidelines which are PESCO, which is petroleum and explosive, and these are the standard storage guidelines for any of the fuels across the world. They have got similar standards. COMA standard is in UK. But what we need to do it is we need to follow all the codes and standards. If we don't follow them, then we are going to be into trouble. Hydrogen is an explosive gas. It is not straightforward. So my only thing is, whenever you are planning to put a plant, ensure that safety is taken care of. And in terms of the safety code and requirement, again, I don't want to go into a very hardcore technical details. This is standard ASME section 8 boiler pressure vessel code, which we need to use it. And we need to provide that there are adequate safety distances which are provided when we are going to design the plant. If you see the plant, I would like to take you to the layout of the plant. Can you see the layout of the plant? Here you see is the electrolyzers are only one which are housed in the closed, enclosed area. Balance everything is in open. But what you need to do it is, wherever you are going to have the hydrogen storage systems, they need to be adequately spaced from the building. That's a PESO standard which we are going to use it. But safety, very, very important. We can't take a chances on safety. But if you see the plant, it's a very, very simple plant. It has got a water treatment system, it has got a storage system, and then the biggest thing is the high voltage. High voltage, that means 400 kV system. You need to draw the power and ensure that gas insulated substation system is provided there. So these are the 3 or 4 components. Else, it's a pretty simple plant. Now here comes some important things which you see. Capital cost. Somebody was asking here, what's the cost? It is 12 crore rupees per megawatt. And what you are going to produce is 200 kg per hour from a 100 megawatt plant. These are some statistics which you will be using it when you are going to use a feasibility study, whether you want to put a plant or not. And other area which you see is the main plant uses on 100 megawatt, whereas the rest of the plant uses only 10 megawatt, which is for cooling system. Now, in terms of plant life, it is about 25 years of life. The biggest issue is power. the green power availability. And it is not available round the clock. Sometimes you need to reduce the capacity of the plant, and you can go up to the 10% of the capacity of the plant. That means the turn down ratio is about 10%. Now, here comes a big issue here. If you want to produce a gray hydrogen is available at 250 rupees per kg. Whereas the green hydrogen, if you want to produce it, you cannot have a payback period of 6 years unless you have got a selling price of 400 rupees a kg. And that too, with a subsidy of 50 rupees kg from the government of India and a subsidy of 35 rupees in terms of the carbon credit. So the viability of a green hydrogen plant is not so simple. So government has to really support it. Now key takeaways from this thing, that means for every ton of a green hydrogen, we are going to get a 10 metric ton of the CO2 credit. And that's the biggest thing. If you don't get a CO2 credit, and if there are no ESG norms, that means nobody is going to produce a green hydrogen. Green hydrogen is mainly meant for creating of getting a carbon credit. Otherwise, the steel which you are going to sell it, if it is not a green steel, it is going to have, the government of India is going to levy about not government of India, the European Union is going to levy a 40% duty because of non-green steel. So that's going to be, it's a essential thing. It's not that it's a choice. Meeting a ESG norm is really essential. So that's something which I just wanted to say. Otherwise, green hydrogen, if there are no ESG norms, viability of green hydrogen as on date is pretty difficult. Reason being, we have got 5.3 kgs, 5.3 kilowatt, which we needed for 1 kg of the green hydrogen. Thank you.